The minimum standards for PRNAV operations are a navigational accuracy of ±1 nautical mile for 95% of the time, the ability to fly accurate tactical offsets, protection of the navigation database against modification by the crew, and the requirement to link the RNAV system to the flight management system and the autopilot. RNAV of sufficient accuracy is now seen ultimately as providing a replacement for all ground-based navigational aids. Although the only reliable and extensive GNSS presently available is the GPS coverage of the US Department of Defense, there is also the operative Russian GLONASS system and the planned European system Galileo, which is due to be fully functional by 2020 but may suffer further delays. A satellite navigation (SatNav) system is a system of satellites that provide autonomous geospatial positioning with global coverage. It allows small electronic receivers to determine their location with high precision using time signals transmitted along a line of sight by radio from satellites. The signals also allow the electronic receivers to calculate the current local time to high precision, which allows time synchronization. A satellite navigation system with global coverage is termed a Global Navigation Satellite System, GNSS. To calculate a correct three-dimensional position, the satellite transmits signals in the form of data. This data is then processed and calculated by the receiver for the correct distance. The heading information is derived from a flux valve magnetometer, which senses the Earth's lines of magnetic flux. Each AHARS has one detector located on the wing to avoid disturbances. This information is processed and sent out to the PFD to generate the heading display. A leg type describes the desired path preceding, following, or between waypoints on an RNAV procedure. Leg types are identified by a two-letter code that describes the path, e.g. heading, course, track, etc., and the termination point, e.g. the path terminates at an altitude, distance, fix, etc. Leg types used for procedure design are included in the aircraft navigation database, but not normally provided on the procedure chart. Modern airspace has a set required navigation performance, RNP. The aircraft must have its ANP less than its RNP in order to operate in certain airspace. The maximum allowed position error is expressed in nautical miles. RNP refers to the level of performance required for a specific procedure or a specific block of airspace. The departure sector for a straight-out departure extends 150 meters left and right of center line and extends 15 degrees to the width of the airway or departure segment. Minimum safe altitude is a generic expression used in various cases to denote an altitude below which it is unsafe to fly due to the presence of terrain or obstacles. An ICAO definition of the term minimum safe altitude does not exist. The MSA is found on the plan view of an Instrument Approach Procedure, IAP, a standard instrument departure, and on standard terminal arrival route charts. Topography indicates high terrain elevation, as well as coastlines, water surface, rivers, cities, or other geographic information of interest. The color coding of terrain elevation on charts depends on the provider, but usually starts with a light color at airport elevation and changing to darker brown the terrain elevation increases.